Unfortunately, people can choose their own name.
Yeah.
I'm sure Darval's probably correct. Darval Thacker.
That's quite, yeah, it's quite unique, isn't it? Yeah.
Well, there's some of us have very unique names.
Yeah.
I think people were waving that we're live.
Okay. Could, if possible, if the Bradford University and Bradford Council team could turn their videos on so we can see them, that's good.
Right, hi Darval. Shall I admit everybody else then? They're all joining.
Welcome everyone. This is the ODI Leads Air Hack Hackathon, not a hackathon, virtual hackathon, not a hackathon session. And if you've been on a Zoom before, you'll be people will be joining. It takes a little bit of a while for people to get on the stream. Okay. So my name is Paul Connell. You'll see the ODI Leads team with their striking black shirts, and they're branded, and some of them have got air hack backgrounds as well. We'll be joining you in. This session is going to be recorded, and if you would prefer not to be recorded, just let us know, and we'll work to edit you out of that. And Air Hack comes out of our long-standing work with Bradford Council on open data, on open innovation, and also working on things that matter to the city and the city region. So it's something that's important to lots of people. So it's core to our mission, and Air Hack today is part of our Planet Data work. We've just had a session this morning, an online event with about 10 speakers, 60 to 70 people online joining in. We're not quite sure if you've ever looked at web stats. We've actually had 140 people registered, but were they unique views or were they individuals? We're not sure, but this is part of that, and you're all very welcome to join us. It's part of the SCORE projects that Bradford Council are doing, and that's a global, well, European project, mainly with people in Stockholm and Sweden. The Bradford team will share a little bit more about that in the future later on. Today, what we're going to do is, I mentioned a hackathon, not a hackathon, is that, and if anyone's ever been to an unconference, what we're going to try and do is get the people who've joined the call to work out what is most important, what they want to share, whether there's questions they have, whether there's specific things they want to work on, but create a space over a couple of hours where we can have a discussion and make some progress around things that matter to us that are on the call and that are involved. And ODI Leads has got a demonstration of a product that we put together using the data, but it's also, hopefully, will be the start of something for a number of people, and also the start of a way in which we use and share data about air quality. And air quality is always mentioned when we talk about environment, and it's always assumed that it's very easy to get this data. But then, where do you put your air quality monitor? What do you monitor? Do you monitor very accurately and very precisely, or do you monitor at a more broader level at more data points? And what does a very specific reading around NOx levels means to people's lives? It becomes very, very confusing very quickly, and it also becomes our instinct for simplicity goes against the complexity that sits around atmospheric conditions, travel and transport, emissions from cars, and what does that actually mean? So it's really a fascinating project, and as a long-standing environmental data nerd, I get really quite excited about all this. So it's quite interesting. And then what's the accuracy of the sensors that we're using, and what's the quality of them? And there's lots of different questions around air quality, which can be simplified, but also we need to understand its complexity as well. So Bradford they monitor air quality from a statutory perspective, and they have those data, but they've also been starting to collect data at lots of different data points across the district to try and make sense of all this complexity, and then try and make it useful and applicable to real people and real lives, if you like. So welcome. This is my introduction. Giles Dring, who's on the line, is going to co-host with us this afternoon. And after we've had an introduction from the Air Hack 2 partners, Bradford and Bradford Council, what we're going to do is ask people to put their name in the chat function, share with us what they want to talk about today, and then we'll try and organise ourselves into some sort of fashion that we make best use of our 2 hours that we've got together this afternoon. So Giles will jump in after we've had, I think it's Sid and who else from Bradford Council are going to be speaking this afternoon? Sid, Sal, yeah. Sal. So okay. You got the light behind you, so you can't work out who it is. Yeah, there we are.
I've just tried to put Kermit the Frog instead, but it made it worse, not better. Sorry about that.
That's okay. So Sally is going to join as well. So I don't know who wants to go first. Is it Sally or Sid?
I think, well, my introduction is about SCORE. Do you think I ought to tell people about SCORE to begin with? It's not all about air quality, this one.
Okay.
Go for it.
Sorts of things. Yeah.
So what we'll have is Sid's going to tell you about the SCORE project and what it's doing, and we'll give you 7 minutes maximum to do that. Hopefully we'll get through that. And then we've got Sally up
more than
to talk about the data that we've got from Bradford. So over to you, Sid.
Okay, so hopefully I'm sharing my screen now.
Yes, that's working.
Great, and I'll start the PowerPoint. It says, here we go. Now this is going to take more than 7 minutes, I'm afraid, but I better rattle on with it then. My name's Sid Simpson. I work in the drainage section at Bradford Council. And I'm not an expert on air quality, but very keen on the concept of open data and open solutions. So this is what the SCORE project's all about, and the SCORE project sponsoring this event this afternoon, Air Hack 2. So SCORE, Smart Cities and Open Data Reuse, is a project that comprises of 9 European cities, including Bradford, across 7 North Sea countries, and has the city of Amsterdam as a lead partner. And as well as the cities, there are academic partners such as the University of Bradford, Aarhus University, Amsterdam Data Science, and Johannesburg Science Park in Gothenburg. It's part of the Interreg program, which is funded by the European Regional Development Fund. The Interreg program, it's administered across several European Union regions, including the North Sea region. And SCORE is part of Thinking Growth, one of the programme's 4 main priorities. And this recognises the role of the public sector in generating growth and helping stimulate innovation, which is what we're hopefully doing here today. The SCORE project is looking at challenges across 4 themes: mobility, environment, water, which I think should go into environment, but anyway, and a general area for data and data tools. And within these challenge areas, we're developing solutions to common shared problems that public sector organisations face. We're looking for open source, open data solutions wherever possible. However, large public sector organisations, such as Bradford Council, have proprietary systems and software, often using data under restricted licensing agreements. So we've got to be flexible and look to produce adaptable solutions to take this into account. We are, however, hoping to unlock data and publish it as open data, just like the air quality data we'll be looking at today. The idea is that solutions are easily reusable by other organisations so they can make savings by using them as an off-the-shelf resource. And SCORE's got good working links with other leading organisations like the ODI and also Open and Agile Smart Cities and the Foundation for Public Code. So for the rest of the presentation, I'd like to tell you about some of the things that SCORE partners are working on. With so many partners, I haven't nearly enough time to mention everything, but here are a few examples. So the city of Aarhus in Denmark is working with Internet of Things technologies to monitor city assets. Life belts, for example, are important and obviously need to be in place when they're needed, but they can go missing, especially in a university city. We all know what students are like. So Aarhus has attached GPS trackers to life belts, so they're alerted when they're moved and they can track their position so they can be recovered. For fixed assets that might be vulnerable to flooding or fire, Aarhus are installing simple LoRaWAN heat and moisture sensors that can send alerts if they are flooded or if they catch fire. They have a common IoT platform and follow recognised standards and procedures using off-the-shelf hardware within the city's own license-free LoRaWAN network. So they're looking to use an open source IoT server and ThingsBoard IoT platform, which will enable them to publish the data as open and integrate it into their own dashboards and alarm systems. In Bradford, both the council and the university are partners in SCORE and they're developing several initiatives. For example, the university are looking at a citizen science as a service and have developed a flood reporting app, which will very shortly be trialled with local communities in Bradford and another SCORE partner city, Aberdeen. And yeah, the council's installed a range of real-time monitoring devices to measure rainfall, river flow, and soil moisture for the council's natural flood management schemes. Of course, air quality is central to the work of the council and the research at the university, and we're going to hear more about that today. But there are more details on the SCORE website. There's a blog on there. This shows one of the university workshops that are held with a Bradford school, showing them how to construct simple connected air quality monitoring devices, raising awareness of air quality. And I'd also like to point out this video. This isn't a SCORE video, it's one about Born in Bradford and the work they're doing about the health impacts of air quality across Bradford.
Sid, we're not actually seeing those videos. They're still on the presentation. I think you've probably only shared
I'm
that,
not showing the video. I'm not showing the video. It's
okay.
too long, but I recommend people watch it because it's really, really good.
Click through the link. We'll make sure people get access to the presentation after this.
Yeah, there's a few more in there, so that should be good. And yeah, there's another blog about other work we're doing in Bradford. This is about using QR codes. All our litter bins have these QR codes on them now, where people can report problems. It goes into a database and we can manage our assets a lot better. And this is something that's we're quite keen to develop. And this is using image recognition for traffic sensors. So image recognition is a theme that's running through SCORE at the moment. The university has worked on assessing blocked road gullies, for example, from photographic imagery. And this is a possibility here, using drone footage to track and count cars, identify the type of vehicle and the way it navigates a difficult junction. Because tracking vehicles manually across a big junction is really quite difficult. And yeah, Amsterdam Data Science, they're doing a great deal of research into these methods. And I think this is particularly impressive what they're working on. This is an urban object detection kit where they take video footage of streetscapes from vehicle-mounted smartphone cameras, which are analysed in near real time to extract locations where there is, for example, fly tipping and graffiti. And this is something Bradford might be able to use, as we have already got cameras on our bin lorries for health and safety reasons. There's a great presentation again here. We haven't time for it, but I can well recommend it. And the object detection kit, it's an open source platform for cities to help increase the efficiency of their urban services. So all you need is your smartphone. You can put it on your bike handlebars, put it in the vehicle, and from the video it collects, the computer algorithms identify objects saved for fly tipping. So there's wood, there's cardboard, there's a chair here, it recognises it as furniture. Graffiti, it'll pick up graffiti from the video. And yeah, moving on, Hamburg. They're working with a lot of public sector organisations in Germany, developing and using an open source geoportal called Master Portal. And this shows a large range of city-related geographic data. It's an open source product, which is Open Geospatial Consortium, OGC compliant. It's used for visualizing map data across the city. And there's a link to a live demo here, and we'll have it in English. And yeah, so this portal is not dissimilar to one we might use in Bradford, but ours is ArcGIS Online, which is a proprietary system, whereas this one is open source. And there's lots and lots of data in here, a lot of open data. So if we expand that, lots of themes, I don't know if you can read them, but yeah, there's population, health, infrastructure, and environment. So expanding the environment in here, hopefully, if you look carefully, there'll be something on air quality, which I can never spot. Give me a second. Here we go. Switch that on. And this is the Hamburg Air Monitoring Network, the Luftnetznet, which operates 15 measuring stations monitoring air quality. And yeah, we can see some of the stations here. Zoom in and you can click on them and you get details. This measurement was at 2 o'clock, that's European time, so that's 1 o'clock our time. And it's got some values which I can't quite see, NO2 and PM10. And yeah, this shows all sorts of cool stuff as well. They've got oblique aerial photography in there, which you can navigate and zoom in, change the perspective on. So a really, really useful product, which yeah, is open source and a lot of organizations in Germany are using it. Yeah, and moving on. Finally, something a little bit different, an example of open data use from Ghent, the city of Ghent and their digital services provider, Digiopolis, are SCORE partners, and they're really keen to see open data use in their city. So in Ghent, apparently, sheep are used to keep the grass low along the verges in the city. And they've been given GPS trackers so the city can keep an eye on them. And the public are quite interested, obviously, in this bit of countryside in their neighbourhoods. And yeah, there they are. I just hope the drivers in Ghent are a bit more careful than they are in Leeds or Bradford, but yeah, who knows. And yeah, this data, it's on GitHub, the data, there's the code to access it's there, and there's real-time mapping of where the sheep are in the city. So if we go live, hopefully we can find some sheep in the city of Ghent. But yeah, we have one there. I suspect most of them have been taken back to the countryside because winter's coming. So yeah, that's a rather longer presentation than Paul wanted, but there's more solutions coming along. The program's scheduled to finish in 2022. So yeah, there should be more solutions developed in the future. Thank you very much.
Thanks, Sid. That's a really great summary of what the SCORE project does, and I think it shows you the number of people that are involved, and also the scale of the project that's being worked on from Bradford. There's just a quick question from Ruth in the chat. Was is that using TensorFlow? And I'm not sure what you were referring to, but I guess TensorFlow, we know that about. It's a machine learning framework. But Ruth, could you just ask that question of Sid now?
It was about the object detection on the roads, where it was identifying like the obstructions.
Yeah, I don't know the specifics of that project, but the Amsterdam data science team at the University of Amsterdam are developing this themselves. I would recommend going to the video that I mentioned. It's a really good presentation, and it covers the work they're doing. It's about 5-8 minutes long. Yeah, I can recommend that. I'll put the link up in the chat in a minute. That's probably a good starting point for you.
Thanks for that, because I saw a TensorFlow demo that looked a bit like that.
Thanks very much, Sid. Thanks, Ruth. That's great. So what we're going to do now is just kind of Sally from Bradford Council is going to run through the data we have from Bradford, and also the new data sets that have been collected during the SCORE project. So over to you, Sally.
Thanks, Paul. I'm just going to try and figure out how to share my screen. Any tips? Anyone know how to, it's that green button at the bottom.
The big green button that says share screen. Yeah.
Cool. Right. Just a minute. I'm going to try and put a slideshow on if I can.
Great. So I'm just going to go on mute.
Does that work? Can you guys see that?
Not yet.
Not yet.
We do have a copy of your slides, Sally, if you want us to share them. We just have to tell us when to flip through them.
Yeah, that might be the
That's
answer.
easier. Yeah.
Quite possibly, yeah. Oh, that's a shame.
Nice.
Okay, so if you can see, can someone else put the slides up?
Can you do that, Patrick? Are you going to do that?
Yeah, I'll do that.
Fantastic.
Oh, thank you. It's just because there's some pictures on there I want you all to see.
Holiday snaps.
You managed, yeah. So
I think he's just finding them, Sally. So
great.
It will appear in a moment.
Great.
Sorry, can everyone see that fine?
We
Yeah.
see that.
Everyone see that okay? Yeah, so I've provided a lot of data for you guys to look at. Basically, I wanted to just show you the kit that we're using to pick that data up in Bradford. So I just thought I'd run through the 3 different types of monitors that we use. The top one, we've got 3 of these, and they're about the size of, they're called groundhogs, a silly name, but they're about the size of a horse box. And you might be able to spot them when you're out and about in Bradford. But we've got 3 of those, and they measure nitrogen dioxide, sulfur dioxide, they measure a full suite of weather data. They measure particulates as well. At the time when I wrote this slide, they just measured particles smaller than 10 microns, but they also measure particles smaller than 2.5 microns as well now. We've had some new kit put in those. We've also got 4 of what they call a street knocks, which are about the size of a BT telephone box sort of thing. You can see a picture of those, and they're out and about in Bradford, mainly on main roads, so that we're picking up the pollution from the traffic. We've then also got some cheaper monitors, which are called nitrogen dioxide tubes, that we have staff put them out every month and then collect them in again. And they're basically on lampposts that we put in locations that we're interested in. Some of them have been out for years, and some of them we move around, so we get a snapshot in time of about 6 months of data. And then sort of more recently, and what's really exciting is that there's been a lot of citizen science. So we're getting other data in from other sources now, work that the university are doing, that Born in Bradford are doing, and doing with kids and at schools and what have you. So as other people have got more interested, we've got other data sets as well. So just to tell you a little bit about where the pollution that we're measuring is coming from, basically, it's not just vehicles. What happens is in a city, you've got kind of a background of pollution from industry and domestic sources as well. But what happens is next to a road is where it pushes us up into the illegal levels. So there's a lot of interest around vehicle pollution. And next to a roadside of nitrogen dioxide, it'll be about 60% of the road. But actually, when you're looking at particles and other sorts of pollution, it's not just vehicles, it's other things like fires and industry and dust and volcanoes and all sorts of sources. So the focus is on transport and nitrogen dioxide at the moment, because that's where we're failing to meet the EU law. But that's not the only source, and we do need to keep an eye on other things that produce particles, because they're where the big health effects are. If we just nip to the next slide, I'll tell you a little bit more about the different types of pollution. So on the left there, you've got a look at the size of particles that we're talking about. That stick thing is a human hair, and next to it is a grain of sand. And those little particles on there just give you a feel for the scale of them and the sort of things that we're measuring. And on the right hand side is a little vial of nitrogen dioxide, and that's that kind of orangey colour that you quite often get in the sky in the evening as it's settled in the atmosphere, and you get to see it's the colour you get after a nuclear explosion as well, apparently, but I've never been that close. So that's what nitrogen dioxide looks like separated out. Now, the health effects of these two combined and separately, all sorts of health impacts that you'll all have heard about. It's not just respiratory illness, there's cancer, Alzheimer's, strokes, and it actually gets into the bloodstream and is causing circulatory problems because of clots and what have you. Obviously, people who are already ill with asthma, the symptoms are exacerbated, and it's causing around 40,000 deaths a year. It's the equivalent of that, so it's affecting everybody's health, but they've tried to quantify it into the number of deaths so that we can compare it. So when you think about COVID and the reaction as a society we've had to the amount of deaths from that, this is the number that you're getting every year from air pollution, and it gives you a feel for why cities seriously need to do something about this problem. So in Bradford, we've done a lot of monitoring and modelling over time, and we've now developed a baseline, which is the next slide. That slide shows you, gives you a feel for some of the levels that we've got. Anything that's red or orange is actually exceeding the legal limit in Bradford. So what we've done is we've modelled, we've put all the data from the city, all the traffic, the different weather data, domestic, industry, every source that there is, and we've modelled it and we've corrected it alongside our monitoring. And this is the baseline data that we've got, that we've taken to government, and they've said, yeah, you really need to do something in this city. And they will actually, they're funding us to do this work now. And we've been mandated by ministers to say that we have to do it. So it's not that Bradford didn't want to do this. We've been working on improving air quality for years, but really it needs millions of government support to help everyone upgrade their vehicles and deal with this problem. So government have agreed that the problem is serious enough that they'll fund it, and we're now currently doing the work to work out what we need to do to change things in Bradford. If we go, so that's the reason for the interventions that are taking place. If we go into the next slide, this is a real, I put this slide up because I want you to be able to look into this a little bit more if you want to afterwards. There's a Breathe Better website that we've set up that's got all the information about the clean air plan that we're putting in place to deal with that baseline. And there's also a logo on there for Born in Bradford, their Bib Breathes project. They're doing a lot of work alongside Bradford Council to evaluate the changes that we should see in pollution. So they want to see how much health difference it makes. It's the first time this has properly been done anywhere in the UK. So that should be creating some really exciting data that we can share as we go. If we just go down to the next slide, you'll see that what Bradford having to do is to put in a clean air zone. So that's the clean air zone boundary, and that red boundary that you can see will have around 350 cameras around the intersections where the roads come into that area, and there's another inner ring of cameras as well within there that will pick up vehicle movements. So what that network of cameras will do is it will charge older, dirtier vehicles that come into the city. We've had to set standards for what vehicles we can let in, because a lot of the problem that we've got that pushes into the out of the legal position is that we've got lots of older, dirty diesel vehicles coming in, and we need to make it so that people upgrade to cleaner ones. So alongside the cameras going up, which seems a bit punitive, there will be lots of support for local businesses, grants going out to help them upgrade vehicles, and we'll also be able to offer exemptions as well to local companies and SMEs, so that there's been a lot of economic work done around this, and we realise that people are going to need a bit of help with it. So if we go to the next slide, there's some really interesting data as well. I should be able to make all this available as we go. There's going to be stacks of data, guys, that we can do all sorts with. But these slides show you some economic analysis. Basically, our final business case was due in last night. If I look a bit tired today, it's because I was up till midnight working on it. That's picture up on the left. The green one came through at 7 p.m. and needed putting into a load of documents. And what it shows you is the change that we will see as a result of this clean air zone. So you can see in those darker green areas, it's up to a 35% reduction in nitrogen dioxide. And what's nice is when you look down at the right-hand side where the blue and pink super output areas are, those are our most deprived areas in the city. So the biggest improvements are in the most deprived areas, which is a great thing. And one of the reasons why we want to pursue this intervention. So there's also a lot of data around the way people have reacted to the clean air zone, and we've got all sorts of survey data as well. On the next slide, you'll see that we've gone out with a full consultation. I think we've been out twice now. We did an initial survey and then we've gone out with a full consultation in February this year, which included the signs on the roads that you see there. Different surveys went out to taxi drivers, bus companies, businesses, members of the public. Basically, the number of responses we got back, 67% of the public agree with this and they want to see something done to improve air quality. What I've just put down, just out of interest, the sort of signs that you'll see going up in the city, probably at the back end of next year. This clean air zone should be in place for the start of 2022. So there's a lot of work going on to get support out to all those businesses that need it. So the last slide just shows you kind of what the vision is, why we're doing this and what we'd like to see at the end of it. And you'll see that it ties in with a lot of work that's going on for the Transforming Cities Fund as well. You can see Bradford there, and there's areas there that would normally be road that are just full of traffic that will actually be shut off and trees planted instead, and people having a nice time on them, which I think is great. You'll also see down at the left, we've asked in our consultation what people want to see happen. 85% of people want to see electric buses. Loads of people want to see electric taxis and electric vehicles, and people generally want to have the health benefits that come with this. There's going to be a bit of difficulties and practical problems for the city as we adjust, but we feel that we're doing the right thing, and hopefully have the support of everyone on the call as well with this. So there'll be loads of data as we go, and I'll keep you all informed, but thank you for listening.
I'm just coming off mute there. Thanks very much, Sally. It's really exciting to see what's going on and the data and also, you know, why we're doing this and why it makes so much sense to be doing this and why we need data and all that sort of stuff. So brilliant. Thanks very much. I'm going to hand over to Giles, and then Darvel from the university has got a little setup as well. But before we get onto the talk from the university, and we've also got a demo from ODI Leeds as well. I think Giles is going to take you through about working on what's most important for us to work on this afternoon, who wants to join in, that sort of thing. So over to you, Giles.
Yeah, so this is quite a bit of a new thing for us, doing a hack in a sort of a virtual sense. We've run events remotely, and we've sort of got a handle on that. But there's something about being with people in the same place that I think we're sort of missing from this sort of hack event. And I was thinking a bit about this before we before the session today. And typically the real benefit that I see is that you get people coming along with problems they need to solve, challenges, questions they want to answer, and people coming along with things that they've been investigating, bits of data, and you put those two sets of people into a room, and then they go away and work on something for, you know, a couple of hours and come back and you get some amazing things coming out of it. So I'd like to try and see if we can sort of replicate that a little bit. Just it's going to be a little bit interesting to see how it works in this setup. Obviously, we kind of were aware of that when we were setting this up. So we've had a couple of sort of preparatory sessions as a data launch, and then an interim session. I'd be interested by a sort of a virtual show of hands, which you can do with the reactions button at the bottom of your screen. how many people have been along to either or both of those events previously. So I'll put my thumbs up there. I see a few people, possibly people searching around for the buttons. It goes away after a while as well, annoyingly. Well, there are certainly people I recognise here. So there we go. I think I've seen four or five people have declared it, but I'm possibly others. So I'm really interested. Obviously, Sid and Sal have spoken about challenges that they've got, but I'm really interested to see if there are, first of all, if there are people who've got things that they would like to discuss, things that they would like to put on the table that we can, potentially talk about this afternoon. So you can either drop it into the chat or just unmute and cut in. Everyone's being very shy. There was something that came out of, I think, one of the earlier sessions that we in the ODI Leads team have been looking at, which was about interpolation of the background data. So Defra publish obviously sort of the background levels of nitrogen oxide sort of concentrations, and obviously some work has been done on interpolating that for particular sites across Bradford, and the data set we looked at was schools. We were interested to see if we could come up with a way of generalizing that kind of approach and coming up with a quick and easy way of dropping a pin on a map and looking at that. So we've got something we can show that we've looked at already around that, and I think that's an approach that we could generalize out to other sort of geographical grids of data. So
just to say on that, Giles, so I've been working with Adrian and Sid on that baseline that I showed you.
Yeah.
That is 1 by 1 meter grid.
1 by 1. Okay.
Of predicted NO2. Yeah, that's been corrected with all our monitoring.
Yeah.
And Adrian's working on making it so we can put a postcode in, and people can go to their own address and see what the pollution's saying there. And then we'd also be putting that alongside what we'd look like in 2022 with the clean air zone in place, so people can see. Oh,
that's really great, actually. Yeah, because obviously the Defra data set we're working with is a kilometre grid square, so that's that's obviously pretty broad, and the interpolation you can do between points there is a little bit rough and ready. It's probably not too bad, but but there are clearly there's factors like local landscape and building layouts and all that kind of stuff that will have an impact on that, which I guess you have probably taken more account of than we.
That's right. Yeah, we've got all the LiDAR data in there, and the topography and what have you. So it takes account of those things and gives you a much more accurate picture.
Yeah, that's really cool. So yeah, I think that kind of it's almost also a way of well, as you say, sort of doing the thing that says where are you now versus where are you in the future, but also the thing I really like about the Defra data sets is that the way it's sort of broken down into the sources of that, so it enables you to sort of drill in and say, well, what contribution do motorways or the airport or whatever have on pollution in this area. So it's a really great way of sort of exploring around the data. So we'll show you that in a moment, but are there any other sort of burning issues that people would love to sort of bring to the table? No. Oh, Paul's waving his hand.
What's the most important contaminant to measure for? So talk about NOx or particulates or carbon monoxide or soot, so what are the things that we're most worried about?
It depends what your perspective is, Paul. So if you are summoned by government to look at legal limits at the moment, it's nitrogen dioxide everyone's interested in. So that's the one where we're failing to meet the legal limit. If it's health that's your concern, which is also obviously the council's concern, and we share that, we'll be looking at particulates, and that's why we've installed those PM 2.5 monitors in the groundhog type stations that I showed you, because public health have paid for that, and they're really interested in seeing what ultrafines and really small particles we're breathing in. So bit of both, but we have both covered. I know there's other pollutants that we aren't anywhere near the legal limits that are probably really important, like dioxins and other things, but we don't measure those because we're nowhere near exceeding the legal limits, but other people might be interested in those.
Okay, yeah, cool, thank you.
There was a question actually that I asked, which I'll ask again. I don't know if you saw before, Sal. I was interested in whether that citizen science stuff, whether that's incorporated information from personal trackers like plume devices, that sort of thing, or whether that's something that you've kind of looked at. So
Leeds University are doing some work around personal exposure, and Brown in Bradford have as well with school kids. So they've sent them out with like a backpack on. Yeah. And they're measuring actually as they go, and they can see things like if you walk on the wrong side of the road where all the traffic's queuing on your way to school, how much that increases exposure of kids. Yeah. So yeah, there's some really interesting stuff around that. Another thing that I thought was interesting around data is that map that I showed you. Basically, it changes throughout the day, so that's like a static picture, which is just not in reality what happens. Yeah. And I think it'd be really interesting to put a time slider on some of this data and see if anyone was able to do that, what happens through the day. So everyone moves into the city when it's high and then goes home when it's not. And it's just interesting in terms of exposure, what that means. Yeah, and particularly with sort of the particulates and the like around, school drop-off, where you get people sort of for dropping kids off and the big queues of cars outside schools. Yeah, we're averaging it. Yeah, we're averaging over a year, and actually that's not what people are breathing when they're there. So on a day-by-day basis. Yeah, exactly. Yeah. Okay, so there's a few good sort of things to think about there, both in terms of detailed, in terms of future projection, in terms of time sliders, in terms of bringing that sort of citizen provided data in there, and as Paul said, the different measurements and tying that up with maybe health data or the like. So a bunch of stuff there. Shall we, Deval, can we hand over to you now to talk briefly, and then we'll come back and maybe think about if anybody's got things to show already. We can talk about our stuff and the like.
Sure.
Great.
Sounds good. Can you see my screen, and am I audible?
Yeah.
Yes. Okay, thanks. This thing keeps doing something. All right, so okay, so I think we have a small demo to do around citizen science, around some of the topics which we're just talking about in citizen science and data from there. But my 5-7 minute talk is on this topic, which is why use of citizen science for air quality monitoring is hard, but still right thing to do. And this work is obviously part of the SCORE project and a few partners there, Gothenburg, Bradford City Council, but also some of the local partners, DHEZ, University of Leeds, and Bonn in Bradford. So in terms of the group we have in the university, we have an IoT and Smart Cities Innovation Lab, where we're looking at a lot of different type of IoT and smart cities problems and research challenges, including citizen science, which is what we're discussing right now. So I think we have a kind of a, we've been trying citizen science for 2 years now, 1 year for air quality monitoring on and off, and almost 2 years for flood monitoring. So kind of experiences from both the domains. And I think we think that there are 3 main pillars of citizen science. You need to have some sort of methodology and principles to guide your citizen science experiments, which you basically, where citizens are working with researchers and scientists, which is a classic, air quality monitoring is a classic example, as we know. And then you need technology support to do that. And ultimately you are carrying out some sort of citizen science trials. And to guide your methodology and principles, we quite like what European Citizen Science Association, ECSA, has produced. So there are 10 principles, and they're good guiding principles. If you follow that, you're probably doing a good citizen science. So one of the 7th principle there says that you should make the data which you gather open, provided that security and privacy concerns are addressed. So whatever trials you do, the data should be open, the code should be open as well. There is also a question of how do you involve citizens, what level of involvement you could have of citizens in the citizen science projects. It could be contributory, collaborative, or full-blown co-creation where they are heavily involved in a lot of things. And there is also a level 1 to level 4 marker, which kind of talks about the same thing, where highest level is where you involve citizens in almost everything from definition to collection to analysis. So for us, technology support, there was a question around the sensors. We are using in the project Luftdaten sensors for doing at least outdoor air quality monitoring. And that's for PM2.5, PM10, humidity, and temperature. We also, last 6 to 8 months, we're looking at indoor air quality monitoring as well. And again, we're trying to rely on building our own kit. So this is something which is quite raw at the moment, but we have almost at least 2 kits, or for most of this pollutants, we have almost 2 kits to measure them. And we are in a sort of a stage where we are trying to decide which is the best sensor to use for particular pollutant, and how to decide which is the best sensor to use it for, and also miniaturize this using PCB so that you could have a nice kit which somebody can take home for indoor air quality. So we've been doing, in terms of trials, we've been doing, especially for outdoor air quality monitoring, some of the, we've been installing some of these devices, working closely with the partners in the project, Gothenburg and JSP mainly, Bradford City Council, obviously, and others, and working with school children as citizen scientists, to help us to do that, so that we can leave those kits they built outside their schools. Opening up the data as open data, as one good citizen science project should do. We have deployed the devices on 2 sites, and 5 sites to be added, and that we hope to keep this data, produce this data, and make it open as part of continuation of AirHack 2. We want to show you after ODI showcase a little bit on what the initial analysis we have done for this. But also for indoor air quality data, as I said, which phase it is in at the moment. We're also building a data platform for that, again, linked open data platform. And also we are hoping to make that data available beginning of the next year soon as well. So that's the plan, is to deploy those almost 50 to 100 indoor air quality devices to homes. In terms of challenges, which is what my first part of the title was, I think citizen science is hard because a lot of time low-cost sensors mean low quality. So on the right-hand side, one of these sensors on one of the sites had this sort of peaks, which we are not able to explain. These peaks we are seeing in February for outside one of the schools, and we're trying to do some sort of correlation analysis, which we'll show you in the showcase to understand what's going on there. And that brings the problem of issue of communication and how this is perceived with the citizens and different kind of problems it can create if it is taken out of context. Or the other side, we might have tendency to just say that they are not reliable at all. So it's kind of a balancing that out. This is an interesting research area for us. And there are some potential solutions. You can treat them as a referential, indicative, informative. You can also work on calibration and quality assurances. Some of this we are doing for our own sensors as well. Also, the question of engagement is important. Why citizen science is hard is because a lot of projects do fail in citizen science because there is no engagement. If you don't have citizens doing and taking part into the projects, then you don't have the project. And also, as computer scientists, people who are interested in technology, there is a tendency that we treat citizen science projects as a data collection exercise. Instead, what it should be is it should be bidirectional. There should be high level of input from them. So think about co-creation or collaboration, which is what we are hoping to do as well, where you involve them a lot more. But also it should be an exercise bidirectional about education, about raising awareness as well for a topic like this. I think just last two slides. Also the questions around transparency, privacy, ethics, security, and trust without saying, and which are obvious when you're collecting this sort of data from people's houses, people's neighborhood, open areas, things like that. And again, co-creation, making sure people know what data is being collected, addressing ethical concerns, and also making the data open makes some way to go to address some of the trust issues with this as well. And last but not least, we think that we have to think about digital inequality and divide because we are talking about using tech for measuring these sort of things. And again, a lot of times we're targeting vulnerable groups in this experiments, or we don't want to rule out those groups. We don't rule out the groups which don't have internet, for example. Then how do you design your tech and your software, your interfaces, so that it is addressing all skill sets and also where there is no availability of tech. So yeah, I think I'll end with saying that yes, it is hard, but it's still the right thing to do because involvement of citizens in a topic like this is extremely important. And I think Bhupesh and Ramesh from my team will have something to show after the showcase, after the ODI showcase. Thank you. I hope I was audible and I was not only talking to myself.
No, we came through loud and clear. Thanks very much, Deval. We're just following. There's a question come through on the live chat on the AirHack webpage. We're trying to work out who it's for. The question is, don't the legal limits need to be updated, and how? I assume that's for you, Sally, and in reference to your comment about the NOx levels being the target that we're focusing on. I don't know if we can clarify that, we will do, but I don't know if you've got any initial comment on that.
Yeah, very topical, correct. Yeah, and that is actually what's happening at the moment with the environment bill that's going through Parliament just now. Basically, what they've done is included particles. So there's going to be a load of research done as to what that new limit should be. Mm-hmm. What I expect it will be is that they will have like a reduction target. So it kind of won't matter what your levels are. They want to see it come down, which is a really sensible way of doing it and saves people chasing around after exact numbers. They'll also be talking about reductions in exposure. So there's a lot of money being spent at the moment to reduce nitrogen dioxide at particular little points, when actually maybe that money would be better spent reducing it across the population. So we've seen that in Bradford. That's why we've got that huge clean air zone instead of there's been millions spent in other cities dealing with one tiny junction, realigning it and reducing air pollution that way. But obviously we can see it's a citywide problem.
Okay.
But yeah, millions has been spent pursuing those legal limits. So it's important that they get that right. It's a good question.
All right. Yeah. Thanks for that. Okay. I think Stuart, could you give us a brief sort of overview of what we built in terms of our Explorer?
Yeah. So obviously, with the hack days, people are all showcasing their different things that they've made for this. So let me just share my screen. And obviously we had limited data available. We took, correct me if I'm wrong, Giles, it was the Environment Agency data that was a 1 kilometre grid. So we made a Bradford NO Explorer. NOx is the data that it has in it. Obviously, we're not specialists in, can you see this, by the way?
Yep.
Very good. We're not specialists in air quality. So we're just been trying to understand what is being shown as well. I'll just have to slightly move Zoom interfaces out of the way because I can't quite see what's going on. So there's different layers. These are the things that are in that Environment Agency data. We had to, they're called things like motorway in 28 or motorway in 18, motorway out 18, which we realized were production of NOx from that source inside the grid cell and from outside the grid cell coming into it from nearby places. So if I change to a slightly more dramatic color scheme, you can see the whole of Bradford a bit better. Now the little crosshairs give you a value up here in the top right of what the value is. As you move around, it tells you the value. You can zoom into a particular point. So we wanted to find the train station in Shipley, somewhere around there. So that's the value. And zoomed out, it's moved. So that's the value there for the total NOx. Underneath, we've got a breakdown of the sources and the different values that are contributing to that total NOx. We also just added a postcode search. So if I search for BD1AA, that takes you to the centre of Bradford and gives you the breakdown for that postcode. So it's quite basic. You can change into different colour scales. We allowed for some kind of interpolation because there was a Bradford data set published for schools and that was interpolated, but we weren't really sure how the interpolation was done. So we were just playing around with either just taking the nearest grid cell value or taking a mean of neighbours or a slightly more smoothed approach using a Gaussian with a 0.5 kilometre radius, a 0.5 kilometre width. So the Gaussian to smooth things out. But yeah. And you can obviously, let's show you aircraft. So aircraft local, if I switch back to that Viridis colour scheme, there are no aircraft taking off in Bradford, unsurprisingly, but if we switch to aircraft remote, you can see where Leeds and Bradford Airport is just off the edge here, up in Eden. So that's a quick summary of that. And that tool is on our GitHub page, idleads.github.io/airhack2-NO Explorer/map. You can put links there in the chat.
Cool, that's Stuart. Love it. That's really clever. Just so you know, that data that you've used there, Stuart,
yeah,
we've put that underneath our, the modelling that I showed, the baseline that I showed.
Right.
So we've put that underneath, and then because you can take out different lines of it. So for example, the local traffic, we've took out and then used our strategic transport model to put the traffic back in. So we've taken elements of it, and there's things like we've got an incinerator going in the valley. So we've taken the emissions for that and modelled those explicitly as a point source, but kind of used the background to calibrate it all underneath. It's really interesting to see it like that. That's great. I'll go to that link and have a look at it.
Right. I mean, mostly we just wanted to visualize it to try and get a handle on what the data looked like.
I haven't seen it before like that. That's cool.
Right. So okay, glad it's useful to somebody.
This is what we'd hoped, yeah. And well, I mean, for us, it was a really good way to get our head around what this stuff was telling us and what it was trying to tell us. And obviously, we know that it's a very large grid. We know it's a 2018 figure, and there are predictions that we could, move forward on. And obviously, there are far more refined ways of using it, as you are. But just to sort of visualize it on a single plane was really helpful for us. Just getting our head around it, and I think this technique you could I've actually done it for the entire north of England. That's a very, very big file when you try and do that in QGIS, but yeah, it's a really good.
As soon as we've got sign off and it's been for all the technical review panels at government, I'd be really keen to give you our 1 by 1 meter grid and let you guys have a look at that and have a play with it.
I think we'd need to do a bit of pre-processing. I think
it
would probably cause
big files.
Yeah, probably cause various browsers to sort of melt down in the meantime. But yeah,
I'll just also briefly add that for anyone bothered about privacy, the postcode search we've done it's very simple and it should protect people's privacy because we've split Bradford up into like BD1, BD2, so it just grabs a whole file of BD1 postcodes. So don't worry about your privacy if you're searching for your own house. We don't know that you've searched for it.
So I have a question for the data guys. The interpolation of the data for schools is something I did using GIS software, but I don't know particularly that much about different interpolation techniques because it's all very mathematical, and the different functions available give slightly different result. So is there a suggestion, if you like, that you could make which would be the most suitable way to interpolate this sort of data?
Sal might have an official response. Just from looking at the data and my background, we tried having no interpolation and it doesn't make a massive difference to the values really. On that 1 kilometer grid. I mean, if you've got, it depends on what your data is. If you've got one meter stuff and you don't need to interpolate because that's good enough, I think, if you've got 1 meter resolution. Or the 1 kilometer, you could have a linear interpolation. I mean, the smooth one we did basically sort of weights nearby points. So the closer they are, the more weight they have. And then as they go further away, it follows a Gaussian distribution. So as they go further away, they have less and less weight, and that's quite a compact thing. So the ones really on the edge are not contributing. The downside of smoothing like that is that if you have a sort of hill, as it were, if you're at the top of, as Giles was saying earlier, at the top of Snowdon, and you average the points around the top of Snowdon, you end up with a point that's below the summit of Snowdon, because all the points you're averaging are either the same as the summit of Snowdon or slightly less. So it has a tendency to bring down peaks and bring up troughs.
So my understanding is there's a method called kriging, is it? Which looks at the shape and the trend, which sort of allows for that. So it actually extrapolates as well as interpolates.
Right. So it's sort of fitting a surface.
Yeah.
Right.
Yeah. But I'm not an expert. I'd like to learn more, but it is really mathematical and complex.
Yeah. I mean, we've started with the really, really simple stuff on the basis that, as Stuart said, it's sort of good enough, and it probably replicates the work you did on the schools piece. So, yeah, the linear one is basically just take the 4 points and give a weighted average between those 4 points and give that as a number, and then Stuart said a little bit more smoothing on top of it, but I think. Oh, sorry. Somebody was trying to cut in. Sorry, I didn't think it was that funny.
It's Adrian from Bradford, actually. I don't know if it's appropriate, Sally. I've got and I need to call you because this data is just, as you've said, there's just so many records. It's really difficult for me to get my head around. But I could share a screen whereby I can show you the number of points in a property if it's of interest.
Because it is a very symmetrical.
Am I allowed to, Sally?
Go for it. Yeah.
I'll see if
you saw it here first, guys.
Okay. All right.
Exclusive data drop.
Quick, everybody screenshot. I know it's all right. It's on YouTube. Wow.
So I don't know if you can see my screen because I can't see what you're seeing.
Yes, we
But
see that. Yeah.
as you can see, there are over 250 million points for the area that we're looking at. Sorry, my wife's also working in the same room as me, so you might be able to hear both of us, sorry.
That's fine.
Yeah, but for instance, even on that one, in the same property boundary, there are nearly 400 different points. So it's something me and Sally are going to have to get together to talk about how are we going to represent that on a map, or how are we going to be able to do that. And then hopefully, depending on what we do and how we share it with the rest of the world when it becomes open data.
So each of those is what is a not a measurement, but it's a prediction of NO2 levels at that point. Is that correct?
So it's 1 by 1 meter that it's been plotted.
So this is the
modeled.
meter grid you were talking about.
Yeah.
Right, okay. Yeah. Wow. Okay.
So
and the other side of the interpolation that's interesting is we've got different years. So we've modelled 2018.
So that would be from my team would be Ramiz and Bhupesh.
Okay.
Bhupesh, if you can share your screen, please.
Hi, yeah, I'm about to see. Trying to share my screen.
There we go.
Yeah,
Yeah.
it's coming
Can
up.
you share my screen?
Yeah,
Got it, yeah.
Right, yeah. Yeah, so am I audible?
Yeah, you are.
Yeah, okay, hi everyone, good afternoon. So this is, as Dhaval explained, this is me and my colleague Ramiz, we're going to present some of our initial observation and analysis, what we have done so far. So as even Dhaval mentioned, so this, whatever sensor we have deployed at our station or our measurement stations, this is being the similar work that our school partner at Gothenburg have done, and they later then they used the sensor, the way they install for monitoring the outdoor air quality. Exactly, we try to replicate their approach in our case. So here I would like to bring my colleague to explain about our experimental setup. Over to you, Ramiz.
Thank you, Bhupesh. Hi, my name is Ramiz Qureshi. I'm the PhD researcher in University of Bradford. Well, regarding the air hack, we built sensors in last year, October 2019, and as inspired from the Gothenburg, we built a kit which measuring the PM 2.5 and PM10 with units of the ppm. And also we deployed the sensors called DHT22, which measure the temperature in Celsius and humidity in percentage. So in the Yorkshire region, we deployed the sensors on the roof of top roof, height of around 12 to 13 feet. And we are receiving the data on our server. So we have the data since October 2019 till February 2020. But unfortunately, the lockdown effect, the power supply was cut off and we are unable to get data from that sensor. So now the days are easy, so we have access of that sensor. So we do some maintenance work and the sensor starts sending data from the September 2020. So we have the data, but we observe that data and we work on it. So Bhupesh will explain what we observe from that data. Bhupesh, to you.
Yeah. So yeah, yes, as Dhaval has mentioned, so our plan is we already have deployed 2 sites, and our plan is to have at least 5 different outdoor sites and to make some comparative analysis and how it has been, the study shows the different levels or readings at different locations, and also we'll make it the data available to this platform for everyone to see our observations or our analysis of those 5 locations. As you see, this is one of the analysis of one of the locations, and as Ramiz said, we have because of Corona, our power gets switched off, so we don't have continuous data from last October till date. So we have from October 23rd to till 17th of February 2020, we have some data, and then we recently started receiving data. So this is our observations. We simply plot how PM level, 2 level, and PM 2.5 levels varying, and these measurements in ppm. So over the so this is so the daily average daily plot of across the different months, and we can observe there are some, most of the time there are normal during the October, January, and December, as February as well, but in November there are lots of high peaks, and there are other, and similarly in other months we do have some of the peaks, and which is quite high. So but yeah, since it is a low cost device, but we're trying to interpolate, or we try to correlate what could be the possible reason by gathering some more information and some supplementary data set. So our plan is to, now we're back to our normal data receiving. So when we receive data from October and November months, then we can compare this data set with the last year data set and try some correlation with mobility data in terms of traffic, mobility, and others. So though the days are the activities are normal, but we believe there are less mobility, less volume of traffic compared to the last year. So hopefully, if there is any correlation or not, so that is still need to be analyzed, and we are collecting data, and we'll happy to publish our observations in coming days. We also try to do with this small data sets some correlations. So in the right side, you can see some numeric values there, so how they are correlated to each other. So we have just correlated with temperature, humidity, with the particular matter. So when we observe and analyze this initial early data, we observe that the temperature has a negative correlation with PM values. So whenever there is a decrease in temperature, there is a rise in PM values. But when we compare the correlation with humidity, we have that positive correlations. So whatever data we have received in start receiving in our server after this recent maintenance of our sensor, so that I want to show here. So it will take a little bit time to load. Yeah. So this is the data we have been observing from.
We can't see your screen. It's probably behind your.
You might just be sharing the presentation.
Yeah.
Yeah. Share.
Let me just. Can you see now?
You know, you have to share. You have to share your when you share screen. You have to share the entire.
I think share again and see if it shows you your browser.
Let me see, probably, yeah. Something.
So I think if you stop sharing your screen for a second and then do it again and share the entire screen, it gives you the option to do both.
This is just what I'm trying. It asked me to just leave the meeting.
Bhupesh, can you stop? Is it allowing you to stop sharing? Because I can share. Okay. Try now. Yeah.
Yeah. So if you can see, can you see now?
Yeah, that's fine.
Yeah, we can.
Yeah, it was somewhere. Yeah, anyway, we are back. So this is the reading we see. So you can see over the duration over last three days how PM10 and PM2 values are being plotted. So some have high values, some has and lower range. So we are interested to how correlates with the temperature. So when we see we plot with the correlation with the PM values with temperature and humidity. So you can see this what we have plotted PM 2.5 here along with the date, and then we compare with how they are interrelated with temperature. So when the temperature value is higher, we can see the PM values are low compared to the, and when the temperature is low, the PM values are on higher range. So it's somehow there is some relation, negative correlation you can see with the temperature. And when you plot with the humidity, so when there is high humidity, so these values are also high compared to the lower. So when the humidity goes low, there is low percentage of humidity. So then the PM values, are also low. And that's what this is just early stage observations. We are not any conclusive, but yeah, what we have find as an interesting pattern in over a few days with the temperature and density. And this is the same relations valid with PM10 as well.
Bhupesh, can you comment on the discontinuity that you can see in temperature around about the 29th?
Yeah, actually,
is there a time gap there that we're not seeing?
Yeah, we haven't actually this data that we collected. There is a time gap. It's not continuous data set.
Yeah. Okay. It was
certain interval.
It leapt out at me because suddenly you go from purple to
no, these are the time gaps where we are not getting data. There's some time gap.
Okay, but I was interested in the one that I'm pointing at my screen, which of course is useless. If you go a bit further across, where it goes from 2809 to 2909, where it goes from purple to bright to an orange colour.
Even
No, no, the left, the left of that. Bit further left, about there.
Yeah.
So so that's 246.
Yeah.
256 on the 28th, and then the next one is, so there is a gap. There's a time gap, I think there.
Yeah, there's a, we are not plotting it continuously. Because over the period of some duration, it will be, since it is just last from 3-4 days, so we can see the time that, but over the period of month, probably it will be more skewed and it will be more continuous. So what our target is to, what could be good representation? We are also not sure, probably the day average or half day average or 6-hour day average. So we'll see what could be the best possible representation once we have more data in coming days. So this is our initial observation, and we are still a lot to collect data and make some analysis, and that interrelate if there is any relation between temperature, mobility, and other data, available data with from third party or whatever. So we will be happy to share in future. That's all what we have done so far, and we're happy to share answer anything so based on our experience.
Thank you, Bhupesh. So I think just to conclude from our side, I think it's a very small data set, especially in terms of the correlation. The data about PM 2.5 and 10 is about 4 to 5 months worth of data, not continuous. There are some gaps, but the temperature and humidity data, because we didn't have humidity sensor before we installed after repairing it, is just less than a week's data. So we want to just continue to collect it October, November, and compare maybe from the last year. One of the things before I open up the floor, if there are any questions, is Sally is there or left? Oh, she's there. Okay, and maybe for others as well. One of the things we're looking at in correlation is not only temperature and humidity. Even in this small amount of data, there is a strong correlation. Other way around, one is positive, one is negative. But also, I think maybe there are other parameters we'll have to look as well, and that's what I was gonna ask. What else we look? We were looking around wind speed and wind direction as well, which Ramesh brought up. That might be something people look at. But what else we might be looking at, or any other pointers?
The cloud cover is important, Deval, because the amount of sunlight makes a difference. Pressure as well, because where you've got an inversion, it'll trap. I'm not sure how that'd show up in pressure, to be honest, but where you've got an inversion, you really get, so like in cold weather, you get like a lid of air over the top of the city and it traps in all the pollutants. So however that'd show up in data, someone else that knows a bit more about weather might be able to tell us that's what we'd want to be picking up.
So what about rainfall as well? We've published some open data on rainfall, and we can extract values at 1 kilometre intervals historically over the last few years from one of our data providers. So that might be a useful resource for you as well.
Yeah, that would be useful, because you can look at washout with the particles, particularly if you've got the rainfall.
I think so, yeah. I think there was already some rainfall data shared as part of this open data dive, but I think we were too fixated with getting the platform right to be able to use all the data, to be honest. We could have used more data for this hack, but we just wanted the platform, our own platform. There is a graph database behind this, and the data engineering took a while, I think, that's why. The other thing I was gonna ask, was I think for the low-cost devices, one of the things we want to do is we want to find out reference. So the question I had was for the NO2 and PM stations we have in Bradford, is the locations are known, I guess, isn't it? If we want to put these devices there and compare the referential values, is it possible to know where those those things are?
Yeah, sure. So we've got a load of reports online that have got all the data in for that. Do you want me to send you a link to those?
Yes, please. I think we are at a
Yeah.
stage where we want to make sure that we have some confidence in these devices, and we're looking at a lot of data analytics methods, and we'll have to look at the referential values. Yeah.
So are you going to co-expose them alongside our kit? Is that what you're saying?
Yes.
Yeah,
yes.
sure. Yeah.
Yeah.
Great. I'll send you the links to the reports.
Okay.
They're on.
Okay.
Pavel, I think all that's already available as open data. I think it's been put on Data Mill North, and
Yeah.
I think we've published some stuff out of the geospatial portal as well. I'm just having a quick look now, and then I can share the link on the chat.
Sure, please.
I'm fairly certain I've seen it in the working document we put together for the data release as well. So I think it's probably in there as well.
Okay.
Yeah, that's probably better than our reports, because you'd have to see.
I would say rather than if we have a data from somewhere, let's say for the location X, and we are putting the location Y. But if you could put our device for a couple of days, a few days, and with the same locations, and then that could be a good comparative for our confidence on our data. Yes, correlation. But if we are just comparing from X different locations, probably that could not be make a good correlation, not good confidence on the. So if we can have, we know that the location, and if we can put for our device for a few days there, and then compare that the high accuracy device with our low cost device, and then matching the.
Are you measuring NOx or particles, Bhupesh?
Yes.
Both kinds.
Particle reduce.
Okay.
And also one question, Sally, so whatever low cost device we have been using, they are using ppm as a unit for measurement, but on the standard of the health data side across the UK or EU, they are saying that this is the limit, threshold limit in the microgram per meter cube. So there's different measurement units. So that is also one of the things we have to calibrate putting at the real location. So how the ppm is levels, is there any correlation or any relations we can establish?
Okay, right. We can talk about that, and I'll show you what units ours are using. Yeah. So ours are in microgram per meter cubed.
Yeah, I think the problem for us, we don't have volume of molecular or mass of molar. So, you know,
are you just doing particle number?
Yeah, that's the low cost device sensor does.
It's just gives you ppm, so there is no direct conversion. And I think what we're looking for is everywhere it's in the other unit in terms of what are the legal limits, or what is critical, what is moderate, what is okay. If we just get what is those limits in ppm, that will also help. Then we don't have to convert.
Yeah.
Because we got we saw some peaks, and we were really scared that these are rubbish devices, but it's just because it's in ppm, the values are quite high, but they might be in micro. The other unit, they might be just 30, 35, which is bad, but it's still we have areas like that.
I wouldn't know how to sort that out, to be honest, because if you could have one particle that's thousands of times the size of another one, and how would you know? You'd need mass as well, wouldn't you, to be able to work that out?
I think we didn't know that these devices are just giving it in ppm. They don't give mass. There is no way to get it from them. But interesting I'm sure we are not the first one to encounter it. A lot of people are using this.
I mean, I think you highlighted it when you first spoke about these, saying that obviously they're potentially less accurate than the more heavily engineered devices, and so consequently they could be used as a sort of a confirmatory, or to give a detailed background, or sort of more detail to the background. But I think understanding these limitations is an interesting challenge, shall we say? And yeah, you're right. In either direction, converting from one to the other sounds like it's not a simple multiplication.
No. How ours works is you've got a filter that only lets the sort of size through that you want. So they're that size or lower to start with, and then it collects the mass. So it basically lands on a little glass rod that's oscillating, and the frequency that oscillates, that changes as the mass increases, and it gives you a reading, but it only allows through the smallest particles. So the PM 2.5, it's 2.5 microns and below, and then we've got a PM10 filter on another airline coming in.
Yeah.
But if yours is just measuring anything in the air, it could be a great big piece of soot, or it could be millions of ultrafines, and you would only know the particle number.
And presumably, it's it's sort of measuring, a contact of some sort, isn't it?
Yeah.
I don't know if it's exactly what is being talked about, but on the Google Doc that we put together, about a third of the way down, there's a section on Bradford air quality reports, and I can't remember now who added this. It might have even been me from a PDF somewhere. There's some text that says Defra data is normally micrograms per cubic meter.
Yeah.
And the formula to go from parts per billion to micrograms, there's conversion factors depending on the temperature.
Ah, yes, I remember seeing that.
I don't know if is that what's being talked about here?
The standard temperature is a 25 degree and 1 atmospheric pressure. And
I presume it's a
measure the weight.
So it's got like 4 examples here: 1 at 25 degrees, 1 at 15, 1 at 10, and 1 at 5.
Just pop the link to the Google documents in the chat for anyone who doesn't already have it.
Thank you, Patrick. I think we'll have to look at that. Yeah, thanks.
So I don't know if you can see my screen, but so we're down here, and that's in parts per billion, I presume, ppb.
So some of our kit measures nitrogen dioxide in ppb, and then we times it by 1.91 to get it over into micrograms.
Yeah.
But I don't think that would help you in terms of your particle number.
Oh, I see.
Okay.
Yeah.
This
but
may be the NOx.
It is important as well.
So I have a question, Darryl. You're looking at correlating air quality against different types of weather, effectively, but isn't there a correlation between those types of weather? So particularly, for example, when it rains, it's often cooler. So how are you going to allow for separate correlations? How are you going to ensure that any correlation you make is valid?
I think that's why I think if I understand your question correctly, I think we'll have to look at individual parameters, one-to-one correlations, I think. This is what we've started doing: temperature, humidity, all that separately, I think.
The other thing is that when it's cooler, everyone's burning the fires as well. So you might pick that up too. So it affects behaviour and emissions. So it's just as long as you list all those things, it's fine, isn't it? But basically in winter, we get much higher levels. And I think it's the inversions, the colder temperatures, and increasing use of fuels as well.
Yeah, and I think we'll have to, as you said, we'll have to at some point, using domain knowledge, we'll have to combine what we are correlating with as well, rather than one-to-one as well, I think. Yeah.
So Sid, to answer you, we have a multivariate correlation analysis that we're going to perform. So there will be not just one-to-one, there will be multivariate.
All right. You probably lose me with the science there, Bhupesh. It's beyond me, things like that.
No, I think, yeah, it's one to many. If the expert says that these are the 3 things you might be interested in to look at, they might be having an impact on this variable, which is 2.5, let's say. Then we have to prove that with multivariate, yeah.
Okay. So right, this is good discussion. I'd really like to follow up on some of this stuff. Ruth, I noticed you mentioned some while ago that you were doing something for yourself, sort of installing your own system. I'd be interested in your plans around that.
So I've got the kit. I mean, Pomeroni sent me a replacement PMS 5003 sensor this morning because the original one, the fan wasn't working. So the plan now is to, like with that arrangement with the 2 bits of drain pipe.
Yes.
You can install the PMS sensor and also the Pi 0 with the Enviro Plus board. So I'm going to get that installed hopefully tomorrow on a drain pipe outside the house, and then Pomeroni provide a Python script for sending the data to Luftdaten I'm going to start with that, and then also look to getting data into my InfluxDB database that I'm using for recording like temperature and humidity in various rooms of the house at the moment. And it's also pulling data from a Met Office feed from the Woodthorpe monitoring station about a mile or so away in Sheffield.
Okay. Yes.
So it's mainly just around getting that working and then submitting to like Luftdart and then whatever other citizen science services.
Yeah. So I must admit, Luftdata is something I only came across sort of today, really. So intrigued to see so much use of it, and presumably it seems to be the go-to place for this air quality related data.
Yeah, I think it's like one of the most widely used, I think.
Yes.
But I also wanted to get to work with what I think there's a Sheffield air quality group, Clean Air Sheffield, I think, that I want to work with as well with that.
Excellent, great.
But yeah, hopefully I'll be able to report back on that in a day or two.
Well, keep us posted.
Will do.
Just looking on the sets of questions, some questions around in terms of sharing. So from Martin, sharing the domain knowledge model. Are you planning to access via a Sparkle endpoint? So you mentioned a graph database, Deval.
Sorry, what was the question? Sorry, I was just a little bit distracted.
Okay, it was in terms of sharing domain knowledge. Are you planning to access via a Sparkle endpoint for the graph database? Now, I'm wondering, is this a confusion over the term graph database? Is this a database to drive the graphics, or is it a linked data?
No, I think it's linked data. I think.
Okay, all right.
Coming from Martin, so you've spoken to him before about linked data and semantics. So, so we have yes. Martin, you wanted to say something?
Well, you've actually answered my question, so thank you for doing that. And yeah, it's nice to see you. I mean,
yes,
my comment on this is that if you like data, there are the data points to be sharing, and then graphed or whatever. But then there is the open data about the domain knowledge model, which it sounds as though you're augmenting this and developing it as part of your work. And obviously, when it comes to actually linking that data and integrating it with other data sets, then you know, with your sort of expertise in semantic technologies, obviously, then you know the actual domain knowledge model itself becomes important to, you know, so that you know the semantic models can be merged or linked in some way, and we can begin to sort of merge data sets from that sort of domain knowledge model point of view. So it's this sort of opportunity for integration, really, in that way. That's just interesting from that point of view. I mean, I realize there are issues around trying to secure Sparkle access points or endpoints. You know, it's not an easy thing to do. So I understand the choices around that. You know, there's more than one audience, isn't there, really, for an endpoint? So I'm just interested if you could just sort of comment on that a little bit.
Okay, sure. So I think we wanted to build everything around GraphDB. So we have a domain model, which is simple at the moment, mainly focusing on outdoor air quality. So what are the pollutants, you know, what are the units, how that connects to the definition of sensors and different type of sensors out there. So it's built around SSN, you know, there is a sensor model, ontological model, and few other ontologies which are out there. So it builds on top of that. So we started adding things around outdoor air quality into that domain model. And more we're working now on indoor air quality monitoring as well. So this is something which we are adding into this. And we do realize that, you know, there is no domain model out there. We wanted to find something, we couldn't find it. So I think that will be definitely one thing we want to contribute to open source, that domain model we will use will be open. In terms of the data, I always feel a little bit scared opening up Sparkle endpoints, because it's not as safe as other things are. So we would do as a lot of people do, which would be putting that as different means. So RDF, XML, JSON, LD, so different formats. We'll put that data, because we'll have to again anonymize some of the things. We're not anyway storing any personally identifiable data, but it would be some sort of data dump in one of these open source websites, including North Data Mill and so on. We'll explore that. Yeah, thank you.
Okay. Yes. Thanks. I should have read the next point down when I've quoted the question, so sorry for going over that, but I think a useful discussion to get out more generally. Okay. Are there any other comments people would like to sort of bring? I mean, there's a lot of good discussion there. Lots of links in the chat in the Zoom room, and we will make sure those get linked out onto the, if they're not already in the document that we've shared via the website, we'll make sure they're in there for those watching online. Not hearing lots of people rushing forward to talk. I'm wondering if we're coming close to the end of what we can productively get out of this hack session, or if there's other things that we'd like to investigate.
Could I ask a question? I'm not sure anybody would know the answer, but does anybody have or would like to propose a value for what we've done monetary wise in the data that we've shared? Or is it just that we're doing the citizen good, the good citizen thing?
Yes, that's an interesting one, isn't it? And I suppose, how would you even go about starting to quantify the value of something like that? It's a thorny and interesting question, I suppose.
I could tell you how much it costs to collect it, but obviously the public purse paid for it, so we all paid for it. But I could give you those numbers if that'd help.
Well, it at least gets us a target, doesn't it? But I think
sorry, go on.
I was going to say, you sort of, the sorts of factors that come into play would be I guess, well, I suppose public health is sort of the major thing. I mean, that's the main, I would guess, the main reason that this stuff is being considered, but also erosion of monuments or that sort of thing. So I guess there's it's the ability to sort of quantify that. I don't really know how to start going about tackling it. If you had something to say, Patrick, then I'll certainly hand over to you.
No, I was basically going to echo what you just said. It's obviously hard to put a value on it, but the most obvious one that leaps out to me would be public health. Obviously, linking that in with health data sets and the other things Giles mentioned. But yeah, as I say, it's hard to put a quantifiable value on.
We have done quite a lot of work around that. So what we've done is work with a lot of health economists from over at York, and what they did was we modelled the status quo. We did it back in, it's all on the website, on the Bradford Council website, but we did like a low emission zone. So it's before the clean air zone stuff came in. Bradford wanted to see if it'd work. So we modelled our baseline and we modelled a low emission zone, and then we looked at the difference between the two data sets, and we worked out from health studies how many micrograms would reduce things by doing that, and what the changes in health would be. And then we matched that back with the NHS costs and worked out within I think it was within 2 years, upgrading all the buses and lorries in the city was paid for by the health costs. So it was really interesting, and there is quite a lot of stuff on the Bradford Council website around that.
See, that was sort of my thought, was that really it's about the business cases that this sort of unlocks, isn't it, really? So, you know, there's clearly value in opening the data, because, you know, people knowing more stuff will lead them to that kind of thing.
So I got some more data just last night on this. They've done like a net present value for the clean air zone work that we've just been looking at now, and it all went in the final business case last night. But they worked out that there is a cost in vehicles upgrading, and that's nearly offset completely by the air quality damage costs, which are actually based on pollutants per tonne and how much it saves in health costs by removing those tonnes. So it's just really interesting when you start looking at the economics around this and all those numbers. There'll be more data than you all know what to do with when I manage to get all this data out the door to you. It'll be great. There'll be some really exciting stuff that we can do with it. Yeah, there'll be loads of it.
So, Sally, I think that's absolutely brilliant that we can give it to the community. You know, I think that's absolutely superb.
Yeah, but I mean, the study itself has cost about £1 million. So everybody's paid for that, and it's really important that data is, and also you get new angles as well when different people look at it and ideas, and I think it's really important that it's shared.
And I think that's what I'm trying to get a monetary value of. You know, it's not the fact that it cost us, you know, however much it's cost us, because the £1 million is probably just the beginning, Sally, isn't it?
Yeah,
you know, adding your time, all the consultants, all the expertise within Bradford Council, etc., etc. You know, it's big money. I think what would be interesting to know, and hence my question was, you know, giving it to the ODI just as one organisation, how much could they put a monetary value on that? And perhaps it was unfair to ask the ODI, but is there a study elsewhere that's saying, you know, open data has a value of, you know, that would be, we have the opposite, whereby we say quite often, we'll say, if you make this data open, you know, it will generate an income of, you know, just to SMEs, etc. But it would be interesting if we knew for this data set if there was a paper or something that was already out there.
I mean, there almost certainly is something. I know that previously, when we've looked at value of publishing particular sorts of data, then it tends to be that it's the direct saved costs. So, for example, not processing of freedom of information requests, that kind of stuff. But actually, this one feels substantively different to that. It feels like, you know, clearly there's that element, but there's a public good, and then there's a, you know, it's taking. I don't know if any of you were participated in the Yorkshire Water event last year about 6 capitals, where they were looking at, you know, a broader sense of accounting, and it strikes me that this is one of the things that fits in there. So thinking about the environmental impact of things that you're doing, whether that be industrial or transport policy or whatever it happens to be, that really fits nicely into that.
It informs decisions. So, for example, I imagine if you had asthma and you were looking at different houses, you might want to put in the postcodes and have a look on our map to get a feel for what's going on. Yeah. What's been really interesting for me around COVID is the data release and the way they've started releasing where cases are on a map. And I don't know what the value of being more informed and being able to work out your own risk factors is, but I think it's a bit similar with this public health issue as well. And it is a really localised effect. So I just think people should know where they live and what their environment's like.
Can I make a couple of... Sorry, Giles, go on. I was just going to add a couple of comments. One was just about a sort of philosophical thing, that given that this data is collected and it's paid for by public funds, there's a sort of moral imperative to really share that, given that everyone's paid to create it. The idea of then defaulting to say, well, we're not going to share it and we have to have a justification why we would share it feels slightly the wrong way around. I think the US tend to be a lot better than us in some ways in terms of public funded things, assuming that it's all owned by the public. And then just another slight point, it wasn't quite, the data wasn't given to ODI, the data was made open to everybody, rather. It wasn't just
we just happened to have picked it up.
Yeah, sorry, Stuart, I accept everything that you said. And I think you're right, the moral argument is big enough. I wasn't suggesting that it has to have value before we share it to the community. What I was suggesting is that maybe we need to look at those that would have the biggest value is maybe the wrong word, you know, but what is the biggest thing that we can do? What's the biggest bang for the buck that we can get?
Yeah.
What would you say to local authorities if you had the choice and we had the ability and you said, give us this because actually this will have the biggest impact?
I think it depends on the context and what the particular thing at the moment. Obviously, this year, health related and COVID related data has become a thing that a year ago we wouldn't have even thought of that particular type of data as being the biggest thing of import in the country. But it has become that. So it just sort of depends on the context and what people need to do. I think we should really do our best to make it easy to publish data openly with as little costs to the publishing of the data as possible. Obviously you've got the expense of collecting it and you want to reduce that, but if you're legally required to collect it, that's down to you. If you can reduce the cost of publishing and make it easy for people to know where the data are, what the data are. So things like in the comments here have been, what are the units? That's a very good question often. What are the units for things? So the metadata describing things so that people can do something with it. And it's not just a big stack of data that people take a look at and then go, well, I don't really understand any of that, so there's no point doing anything.
Yeah, I mean, that was our
to use.
Yeah, precisely, and that was our reason for visualizing the stuff, was because, as I say, we had no real sort of foundation in air quality data, and suddenly being able to seeing it overlaid geographically enabled us to get a handle on it. And it's about, you know, if you're publishing it, then providing the ways that people can use it easily and make those decisions about, you know, whether they should wear a mask today. I mean, you know, COVID aside, you know, for people that are maybe going to be suffering from asthma because of particulates or whatever, then, you know, this is enables them to give to take that choice.
I think there's another element to this that just to sort of explain some of the difficulties with the data is that there's that legal side of it. So we've got potentially big problems if the data isn't what it needs to be. So there's sensitivities around releasing data when you're not sure that you've calibrated it properly, or you need to go through it and check it all and make sure it's worth releasing, when there's sort of a legal side to it, in that you don't want data out in the public domain that says the wrong thing about meeting a legal directive or not. So I think that might be why, if you've struggled getting hold of data, that a lot of it's the legal sensitivities around it. If it didn't matter what our air pollution levels were, there'd probably be a lot less fuss around releasing data sets, I would think.
Yeah, it's that sort of carrot and stick, isn't it, really? I mean, you do things because you have to, or because you think it's the right thing to do. And I think this probably falls into both camps. And sometimes, you know, the citizen science thing, maybe it's more about because they think it's the right thing to do. And, you know, there's all those different things that drive people to do particular things.
Yeah.
Okay, I think we're sort of roughly coming to the end. I just really wanted to sort of summarize, you know, some of the stuff we've talked about. So I think there's some really interesting and useful stuff that's going on, sort of with the analysis that Bradford are doing, and we'd really like to, you know, take a look at that and see if we can help you put that in a very sort of intelligible form, and maybe sort of iterate on some of the stuff we've done with the with our really quick visualizer, see if there's something we can do around that. But then I'm also interested in the citizen side of things. So, you know, the stuff that is going on at the University of Bradford, but also the thing that Ruth talks about in terms of that sort of background. Oh, apparently we've got another half an hour actually.
Giles, could I just say something on
sure.
Forward? So there's basically, Bradford's accepted it's got this legal problem, right? We're taking the plunge, doing something about it, but that presents a few exciting opportunities in terms of data, because we get to see what we modelled would happen, and then we're measuring all the time what really happened. And alongside that, you've got Born in Bradford collecting all the health data and looking at the change that we see as a result of it. And I think it's a really good chance to get some data out there and as many people looking at it as possible to try and see if the changes worked. And we're just going to be, the way to deal with this is be just massively transparent, in my view. So what I'm hoping my job's going to be over the next few years is monitoring and evaluating this clean air zone. So as I'm not the best in the world with great data sets, you guys are, so I'd be really keen to sort of work with you all and share data and get you to help us look at it as we go forward, sort of as an ongoing thing.
Yeah.
Does that sound something you guys would be keen to help with, and all the guys you've got?
Well, it certainly does.
Share all of it, yeah.
Yeah, absolutely. I think you know, as we've talked about, getting stuff published, getting stuff described well, so that people understand how to use it and can cross-refer it with other data sources. You know, suddenly you've got a really powerful sort of set of data that we can sort of we can help inform people's decisions, help inform public spending. And,
yeah, it's public policy as well, and does
yeah.
this work, and what are we seeing, and how much has it saved, and what difference does it make to people?
Yeah,
I think it just needs as many eyes on it as possible. It's new stuff.
Yeah,
we've got ideas about what we think will happen and what should happen, but it'd be really good to look at whether it actually does and what the value of it is.
Yeah, and I think the idea of it being a sort of a two-way street, if you like. So obviously you get input from citizen scientists, but also you're providing to them, you know, your more better calibrated sensors, so that they can sort of assess, you know, and fix up their data sets, if you like. So it's, you know.
And if we don't get where we need to be from all these interventions that we're putting in place, I just want us to be really transparent about that and work out why.
Yeah.
You know, I'll just be able to show you all the methodologies that we've used and what we've done to get us where we are and why we thought what would happen has happened.
Yeah.
And then other people can help us unpick that. I thought the more people, the better, because it is all quite new stuff.
Well, one of the things we found on the Open Data Saves Lives work we've been doing around COVID is the data is one thing, but actually open models are the thing we need, so people understand how the data is being processed, how it's being used to derive you know, findings or produce dashboards or whatever it happens to be. That's a really important aspect. So I think just be radically open. You've got the badge that says radically open, so that's what we
yeah, well, there's all the methodologies, all the assumptions, and they're all written up into reports, so we can just put them out there. The more people that can read those, the better, so they understand what we've done and the assumptions in there.
Great. Yes,
I'd be delighted if someone else would read it.
Well, there's enough people, I think, interested, so
great.
So listen, I think probably we'll that's sort of coming to a natural close. Unless anyone's got anything else to add, then I'll draw it to a close. I'll say thank you very much to the various teams from parts of Bradford and everyone else that's contributed. I found it very informative and interesting, and I'm really looking forward to seeing where we can take this stuff. And Sal will be in touch. You know where we are.
Great, lovely. Thanks, guys.
That's great.
Can I just add obviously a big thank you to the ODI for working with us. Really appreciated. Thank you very much. Thank you to all the team. Thank you.
Thanks very much, Adrian.
Yeah, thank you, everyone.
Yeah, thanks.
Thanks.
Thanks.